Hey guys, so we talked the other day here about the pressure and volume lab while I was gone, and I just wanted to share some thoughts that I had going through your whiteboards. I enjoyed seeing the pictures, the work that you guys did. So we're just going to kind of take a look at that. So the lab was about the relationship between pressure and volume of a gas. If you take a syringe and you set the volume at a certain amount, you measure the pressure using the pressure sensor, what sort of relationship do we get? And there were some options. It could be linear, it could be inverse, it could be quadratic, it could be, some of these different options. So we want to see what the results are. So after going through your whiteboards, there were a few claims that we made, and I just listed a few of them here. Most of them kind of had the same general pattern to it. It was something along the lines of more volume equals less pressure, and less volume equals more pressure. That was a pretty standard response, which I think is right on. That's what we would expect to get. It's always good when you do an experiment and the results agree. So we like seeing that. So good things there with the claims that you made. I think you guys did an excellent job with that part. Evidence. The big evidence here, I would say, is your graph. This is some sample data that I measured really quickly in graphical analysis. It should look pretty similar to what you came up with for a result. And I do just want to point out a couple of things. First of all, notice that the graph, it's not a straight line, it's a curve. If it was a straight line, you would eventually down here get to a point where you had negative pressure or negative volume, neither of which are possibilities. So this curve shape is kind of the better fit. If you played around with some of the other options, you probably found some more complex curve fits that worked, but inverse is the simplest relationship that fits the data, so that's what we kind of go with. One of the things about an inverse relationship is that when you multiply the two variables together, you always get the same result. So my example, pressure times volume, you can see here, pressure and volume, multiplied together equals roughly 952, and that's true for every point along this curve. Your numbers might be different, totally okay. This number isn't that important. What's more important is that when you multiply pressure and volume, they work out to be about that value, okay? That's what gives us this curve shape. It's what tells us it's an inverse relationship. And eventually it'll let us come up with a mathematical expression for figuring this out. The reasoning part of this was pretty good. There were a few things I'd like to see some more of. Generally speaking, we agreed that less space means more collisions with the walls of the container, right? The particle diagram is kind of handy here. Here's a big container, here's a smaller container, and just the particles are going to hit things more often. It's just there's less kind of free space to roam around in, right? Having that drawing in there is really helpful to me to show that you kind of know what you're talking about. I think it helps you guys as well. Just really make sure you understand what's happening and describing it at a particle level. Okay, it's one thing to write a sentence saying, oh, here's what happens and why. It's another thing to have to draw a picture and try to explain it that way. So Pictures are good. More pictures are always something I'm looking for in your reasoning. Okay. I just grabbed a few whiteboard pictures. They were all pretty good. I was very happy with the work you guys did. But I just want to highlight a couple of them. I like this one. Just there's a nice clean graph here. I would like kind of to see that particle diagram. I think it's helpful there. The other thing maybe I would include is what do we measure on the graph? Pressure and volume. So if I'm looking at it, I know which one's pressure and which one's volume, but it's probably a good idea to have some labels on there. Okay. Same thing with the labels here. They had a little data table in there. I would say probably the graph is enough, but I appreciate getting the data in there. I love you got the equation going. You've got all the statistics in there. That's kind of awesome. And a really pretty good particle diagram. I like what's happening with that. It really kind of shows the difference in particle collisions that's happening there. So good job, guys. Here's another good one. Excellent job labeling this thing. That's super, super cool to see. You get that equation there, and you get particle diagram things happening down here, which I like. Just, yeah, all around a pretty good job with this. So overall, I'm pretty pleased with the results. I think we have a pretty good idea on what that relationship looks like for pressure and volume. So knowing that it's an inverse relationship is going to be key. So anytime we talk pressure and volume, if I increase one of those variables, the other variable should decrease as a result. Okay, we know that that's going to be a pattern that happens. So if I take a balloon and I increase the pressure inside the balloon, or I increase the pressure on the balloon, on the outside, the balloon should get smaller. Okay, if I decrease the pressure outside, the balloon should get bigger. Okay, so just some of those patterns and things that we're looking for. So good job, guys. We'll be moving on to our next lab here in a little bit.